Okay. In this time, I will introduce more recent research in our lab. So the topic is the study on the development of affordable robots. So the first one is 3D printed cycloid gear based mechanism in wheel motor mobile manipulator. So in here, there is mechanism platform. Actually, uh, in mechanism platform, they usually use the mechanism here, and we usually use geared motor here. Some geared motor, geared motor in here. So usually platform will be occupy this space. So usually mechanism platform having the space in here. But in this platform, the cycloid gear is inside the wheel, and the motor controller, the vascular motor controller, which is developed by myself, is installed on here. So it is uh, mechanism wheel module. So by assembling 4 mechanism wheel module, we make the mechanism mobile platform. So it have more advantage on the space on here, and using the suspension it can maintain the ground contact on 4 wheels. Actually in mechanism mobile platform, because due to the kinematics of the mechanism wheel, we should maintain the 4 wheel ground connection contact. If some if one of the wheel is lose the contact, it cannot move. It cannot move well. So uh, the suspension mechanism is very important. Actually, this kind of mechanism mobile platform, I already made it on the Naval Labs. I already introduced about M1, the uh, mechanism based mapping robot. So similarly, I made this platform. Actually, one of my student developed this one, and uh, on this platform we added the manipulator. So before then, I introduced the structure of the wheel. This one is the roller, mechanism roller, and inside the roller there is cycloid gear. So the gear ratio is 14 1, 14 to 1. So uh, there is also BLDC motor inside, and using this small BLDC motor, we can produce high torque using 14 gear ratio. And there is also motor controller here. And about the suspension model, we considered the payload and the uh, mobile platform weight. So uh, it is good to make the suspension very smoothly. So we choose light spring weight. So this one is, I will show the video about this one. And the manipulator is on the Mecanon platform. This 6 degree of freedom Mecanon manipulator was composed by the 3D print. So most of the part is made by 3D printer. So in here, 1, 2, 3, having 36 to 1 gear ratio, and this one is 27 gear ratio, and here we have 40 gear ratio, 40 to 1 gear ratio. So this one is first version of our manipulator. Uh, we are preparing to control this one. As you can see, we made it this kind of manipulator, and let me show the video. Now we finish it to develop lower part. In case of a manipulator, we will control the manipulator later. And as you can see, it's very fast and quick. And the mechanism here, kinematics is very good, very well maintained. So as you can see, it can move diagonally, and it can move sideways, and when it go the when it goes go the bump, as you can see, the suspension is well controlled. When it goes sideways, as you can see, the suspension is well function. And I want to introduce vascular and vascular motor controller. This is I already introduced, but I will just more detail. Actually, it has stackable design, and this pin layout is same with the Arduino. So if you put this one, Arduino Mega or Arduino Due, you can control the motor using Arduino. And in Arduino, we can use SPI communication and UART communication and CAN communication. So these three things are functional. So depending on your project, we can choose the communication method. And in vascular autocontroller, it has powerful high power MOSFET. The spec of this MOSFET is almost 300 ampere max. So it is very it can consume very high current, and this processor is very powerful processor, and we having three independent shunt resistor, so it provides very accurate current control. In this video, we show the two planetary gear actuator. It can, if the position control is not well maintained, it can collide, and it can break some part. But when it control the speed control, it maintained in lower speed and middle speed, and even on the very high speed, it can maintain its position very well. So if we check the control status, okay, in this speed we can see it can maintain it maintained. Oh, go back. Okay, as you can see that 90° is very well maintained. So even in very high speed, it can maintain its position very well. And also, in case of the position control, we touch the dial indicator and go back other position and then go back to touching position. It uh, we tested 12 times and we can find the standard deviation of the uh, dial indicator measurement. In, the case, in case of that, we find out the standard deviation, that is uh, the error of the position. So this is 5 arcsecond or 2 arcsecond. So in case of my MJBask, it produces more precise control result. And this is the circular type Bask. So I named it Bascula, Bask plus circular. So I control it very freely. And this is the 3-wheel version of the uh, steel ball control. So in the previous seminar, I introduced this kind of platform, and that was the result when I was in Naval Labs. When I came here, MJU, I ordered the study, the same study to my student, and he did he made a result using uh, this ball plate Omni robot. So when I'm using just PID control, it cannot maintain well, but in case of LQR control, it maintained the stability. In case of MPC, it maintained more well. So now he's studying using HuboQ. So HuboQ hardware will be introduced later. And this one is tennis ball machine. Actually, I like to play tennis, so I made the tennis practicing device. So in the Mechanom platform, I add some ball launcher. So uh, in this video, as you can see, I can launch the tennis ball, and this is the basket, and the ball is feeding through this pipe, and I can practice using this machine. Uh, so it is helpful to practice my tennis. And my final goal of this tennis robot I want to make some tennis playing robot. So in the previous one, it just sending the ball opposite side. But if we can receive the ball from the other side, uh, we can uh, we can make a rally. So I want to make some tennis playing robot. So now I'm practicing about that. So first of all, the first thing uh, to make the tennis robot, oh man, to make the tennis robot, firstly we have to make a platform, some hardware platform. So in case of hardware platform, I tested using this kind of robot. So uh, now I am satisfied about the hardware. And second one is receiving ball. This is difficult part because for this one, we should recognize the ball trajectory. In case of ball trajectory, it's very difficult. If we use the camera, we should predict the ball touching position. When the opposite side they hit, if we hit the tennis ball, uh, there is initial speed and spin. So by catching this information, it should predict the trajectory and where it touched the ground. So the robot should move in that way, and it should prefer to receive the ball. And then if it receives the ball, it should shoot the ball to the opposite side, and the people should receive again. So if we do these things, we can rally the tennis ball. So that is my goal. And for that, the localization is one of the important thing. So this is the result of about that. So using the camera, we can make some bird eye view. Bird eye view is some uh, image view, image similar to the taken from the ceiling. So we can transform the perspective view image to the bird eye view image. So this is the research result about that. So my student uh, studied about this technology using template matching. Uh, if we take some photo, and if we having already the map of the area, we can matching the result from this map, and we can find some position. Then we can find the location where the picture was taken. So we can find the localization using camera. So the uh, result shows the where the image was taken. So actually the map was built by 3D CAD tool, and using this original image, we found we find the taken image here, and using template matching we found this area, and then we can inverse calculate where the camera position. So this is the one of the example on tennis court, and we take the photo in tennis court, and from this result we found the estimation position. There is some error, but we will improve the this we will improve the accuracy. So, and the other result is about the actuator, gear actuator. I have some projects about this one. So we made some high gear planetary actuator, and using this one we can produce high torque, and uh, as you can see, there is some helical gear with no carrier design. So this is epicycle planetary gear actuator made by Genesis Robotics in Canada. So in here, they made this kind of helix gear, and this one is symmetric helix gear, and there is motor in here, motor somewhere here. By using this kind of gear, you can make very power, high power torque uh, without some harmonic gear design. And this is the structure of our uh, gear. Okay, so this is the result. Yeah, the gear is a little bit mm, high friction, but mm, this is due to the 3D printing uh, accuracy. We will improve the accuracy of this actuator. And the other design is uh, here, and it can produce 42.5 gear ratio, and it have it has the carrier design, and we didn't make this one, but mm, this is only we made the CAD. And in our undergraduate experiment class, we used this robot. Actually, this actuator was uh, developed when I study about cycloid gear and planetary gear. And this gear module is very uh, early stage of my design, but uh, it is it is very well uh, manufactured, developed and manufactured. So I'll reuse this actuator for my experiment class. So by using these two gear, I made this kind of experiment setup, and this is used for uh, to study to introduce about Turing planar robot. So by using position control, it can produce very precise position control. Uh, Actually, in this control scheme, we uh, didn't change the position gain, so it is a little bit uh, vibrate, but in this year it will be improved. So one of my students made this kind of GUI tool, and using Odroid embedded PC, and in the loss melodic we control the robot. uh, okay, so this is the prepared seminar material, but more recent research result can be found in my homepage. So in my lab, we have YouTube channel. We upload our research result in this site. Actually, uh, nowadays we did the gazebo simulation of autonomous delivery robot, the HuboQ, using MPC control. So this is the result of my student. When it go high speed mobile, when it go high speed, about over 20 kilometer per hour, there is an object in here. So actually, we already shown the QoQ mobility, but before doing that, I want to show the Kajibo simulation. So I ordered in my lab, and my student this one. By MPC motion control, we can simulate the high speed uh, maneuvering. So as you can see, even in this kind of high speed moving, we can maintain the object very well. And this is trajectory, how it moved, and this is velocity and tilting angle. Uh, in this case, it moves with the H shape, uh, like this. It moves more circular trajectory. And even though in this kind of motion, we can produce uh, very well maintained object delivery. Okay. Mm. I recognize that the Gazebo simulation is very good. So here we make 8 shape trajectory, and this is MPC trajectory, and this one is the object uh, change of the object delivery item position on the plate. So this is millimeter dimension, so it move a very little position change. So maximum slip distance is less than 10 millimeter. So this one is one of the recent research result, and this one is about the Gazebo simulation of 3D printed manipulator. This plate position, this platform already uh, finished to develop almost, but we remained to control the manipulator. So this simulation shows how will we control the manipulator. So in our modern robotics class, we studied about the spatial control of the robot. So the main concept of modern robotics is to control the orientation and the position together. So in case of mobile manipulator, in the previous case, it moved the platform first, and then it fixed the position, and then it moved the arm. So the arm movement and the platform movement a little bit decoupled. But in this simulation, as you can see, the motion is coupled together. So when it move its target position, it move this arm, and also it moves the platform together to touch the target position. So this is the difference of the modern robotics class. So if you in the later part of our class, we will study about this kind of skill. And so this graph shows the BR point of the trajectory. And we gave the trajectory with the trapezoidal velocity profiled trajectory. And then the other research result is about the localization visual odometry using camera imaging. So this graph, this study show the template matching result on the simulation environment. So we make the VLab simulator, and this Mechanum platform move without changing the orientation. When it go this kind of trajectory, you can find you can find the uh, position using vision sensor. So there is uh, four camera here, here. So this four camera taking the photo, and using the result we check the position image. This is the image position taken, and we match this image with the tennis court blueprint image. So we found the position here, and some result is very un uh, some result is not accurate. In the case, we filtered out using Kalman filter. So uh, when we did not use Kalman filter, we have some unwanted error. But in case of using Kalman filter, we can filter out the error position, error result. In case of the circular path, you can make this kind of circular path, and in case of the circular motion, we can get the uh, rotated image. So uh, using the IMU data of the robot, we found the rotation angle here. So uh, different using this rotated image, we check the template matching and found the position of the robot. So as a result, we can uh, precise we can get the precise position uh, odometry. So when we get the mean error of 10 centimeter in the tennis court, in case of using Kalman filter, we can get about 5 centimeter mean error. And also, if we use Kalman filter, we can get the 99% accuracy of position. So it is very good result about the visual odometry. And if we use the encoder data in 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 this simulation result, we didn't encode the data, but if we use the encoder data in robot, we make more precise result in the real environment. So the next goal is uh, to get the result on the real tennis court. So all these things is where all these things is done by our DRCL lab uh, student. So I'm very proud about the result of our lab. So until now, we introduced our um, research result. So uh, this week we I this week I didn't uh, I didn't teach the theoretical content, but uh, we did seminar. In the next week, we will go for kinematics. So uh, we will study about the fault kinematics using screw axis, and um, next week we have the LMS class also, but uh, also we have examination. So this is different. Uh, online lecture will be proceeded, and also we will do our examination. So don't forget to take the class. Okay, today's class is over. Thank you.